So we're going to be writing these net ionic equations just like we've done before. So step one is we need to write our molecular equation. We have calcium. Anytime you have an element by itself, double check, can it be by itself? Calcium is not diatomic, so it can. And it's a metal, so that's going to be a solid. Is dropped in, so plus a solution of sodium chloride. Sodium's a +1, chloride's a -1, so NaCl. And aqueous since it's a solution. Next, we figure out what type of reaction this is. We have an element and a compound, so this is going to be a single replacement reaction. And since it's single replacement, we should be checking our activity series. There's calcium, there's sodium. Calcium is above sodium, so this reaction should go. So sodium gets kicked to the curb, and it's by itself. It can be by itself, so that's fine. And it's going to be a solid because it's just a piece of metal. Plus, and then calcium chloride. Calcium's a +2, chloride's a -1, so we get CaCl2. We check the solubility rules. And so again, there is chlorides. Chloride should be soluble unless it's with silver, mercury, or lead. So now we're going to break apart anything that broke apart. Well, calcium was a solid, so it's got to stay together. No charges. NaCl was aqueous, so it breaks apart, and when it breaks apart, it gets charges. Sodium was a solid, so it comes straight down, and calcium chloride breaks apart. Next, we remove our spectator ions. In this case, the only thing that's a spectator is chlorine. Because notice our calcium doesn't have a charge as a reactant, and then it does have a charge as a product. Same thing, sodium has a charge, no charge. So then our net ionic, we're going to have calcium plus sodium yields sodium plus calcium. You do need to make sure that your charges cancel. We have a 0 charge and a plus, and then on this side we have a 0 and a +2. So we need 2 positives to cancel out that +2, and then a 2 in front of sodium to cancel the sodiums. So charges and elements need to cancel on both sides. So then it says, what type of reaction is this? We have acid-base, precipitation, or redox. Well, it's not acid-base. We don't have an acid and a base. It's not precipitation. We don't have 2 aqueous making a solid. So the only thing we have left is redox. If it's redox, make sure you're justifying by saying what the change in oxidation numbers is. So calcium's oxidation number went from, remember when it's by itself, it's a 0 to a +2. So it was oxidized. Sodium was reduced. It went from a +1 to a 0. It gained electrons. Let's look at one more together. So propane gas, they went ahead and gave us the formula for that one since you don't know how to write the formula for propane. But they told us it was a gas, so we can put a G. Is burned in the presence of oxygen gas. Oxygen cannot be by itself, so that's O2, and it's a gas. We have a hydrocarbon and oxygen, so this is a combustion reaction. The products of combustion were CO2 gas and H2O gas. So since everything was gases, nothing breaks apart. So this is my complete ionic and my balanced net ionic. I just need to balance it. Balance that by adding a 3 in front of CO2, so we have the same number of carbon. We need a 4 in front of water, so then we have 8 hydrogens. And then that gives us 6, 7, 8, 9, 10 oxygens, so then we need a 5 in front of O2. So again, our molecular equation is our net ionic. We just had to balance it. Nothing broke apart because we had all gases. So our type of reaction, it is combustion, but your 3 choices were these 3. Combustion is a type of redox. We also know it's not acid-base. We don't have an acid and a base. And we know it's not precipitation because we don't have 2 aqueous making a solid. But remember, for your justification, we need to say what was oxidized and what was reduced. So for sure, oxygen was changed. It went from a 0. So oxygen's oxidation number went from 0 to, whenever it's in a compound that's not peroxide, it's going to be a -2. So it was reduced. While, and then our other option is hydrogen or carbon. Hydrogen is a +1 in compounds, so probably not that since it's a compound on both sides. While carbon, we have a +1, so that's a +8. It's got to add up to 0, so this has to be a -8. -8 divided by 3. So -2.67. On the other side, our CO2, we had -2, so that's -4. So this is +4. So it went from a -2.67 to a +4. That's more positive. So carbon was oxidized. It went from a -2.7 to +4. Go ahead and pause the video and write your molecular, complete, and net ionic equation. So get down to balance net and then restart the video. For your molecular, you should have said that KOH was a base, and it's a strong base, so that is aqueous. Acetic acid is an acid, but it's a weak acid, so it's going to stay together. So we can say that it's a solid, we can say that it's a liquid, we can say that it's aqueous, but we need to know that it stays together. So I'm going to say that it's a liquid just so I know that it stays together. But in reality, it's technically aqueous. H2O is a liquid, it's going to stay together. And potassium acetate is a salt that is soluble. So looking at solubility rules, all acetates are soluble, no exception. But again, this is for solubility rules, this is for salts. Acetic acid doesn't follow solubility rules. That's why it stays together as a weak acid. This is what you should have gotten for the complete ionic, where everything broke apart except acetic acid and water. Your spectators, you should have said, were potassium, and that's all. So then your net ionic is this, and it's balanced. Now go ahead and figure out what type of reaction this is and justify that reaction. Restart when you have your type and justification. You should have said acid base, and then our justification is KOH is a base and acetic acid is an acid. So it must be acid-base reaction. Go ahead and pause the video and write your molecular, complete ionic, and net ionic. Restart when you're done with those. Lithium is a +1, chromate a -2, iron's a +3, and sulfate's a -2. So we get those products. Lithium chromate is a solution. It's aqueous. We also know that from our solubility rules. Alkali metals are always soluble. Sulfates are going to be soluble unless it's with one of these. Iron is not one of those, so that is aqueous. Lithium sulfate, all alkali metals are soluble. And chromates are insoluble unless it's with an alkali metal or ammonia. It's not, so that should have been a solid. So then for your complete ionic, you should have gotten this. And then your spectator ions are lithium and sulfate. And make sure that you've balanced. Go ahead and pause the video and figure out what type of reaction it is and justify that. We don't have an acid and a base, but we do have two aqueous making a solid. So this is precipitation. So two aqueous solutions made a solid precipitate, which was Fe2CrO43, or iron 3 chromate. Notice that our charges are balanced as well as our elements. We have a +6 and a -6 equals 0, and on the other side we have a 0. Go ahead and pause the video and go through and get your balanced net ionic. Restart when you have your balanced net ionic equation. So in this case, we need to figure out what type it is. It's a single replacement reaction. But if you look on the activity series, you're not going to find chlorine on the activity series. So chlorine is here, and chlorine is trying to kick out bromine. Chlorine is above bromine, so it can occur. Chlorine and bromine are diatomic, so they couldn't be by themselves. When they're paired with tin, tin's a +4 charge, so there should be 4 of them. Looking at our solubility rules, all chlorides are soluble unless it's with one of these three. Tin is not, so that should be aqueous. And then bromine is one of our diatomic gases. It could be a liquid, it could be a gas, depending on the temperature. We can just say that it's a gas. Regardless, it will stay together. So for your complete ionic, you should have had chlorine, and then removing your spectator ions, just SN as a spectator. Our charges are balanced, but our elements are not, so we need to put a 2 in front of chlorine and a 2 in front of bromine. Our charges and elements are balanced now, so that was our balanced net ionic. For our type of reaction, well, it was single replacement, which means we know it's a redox. But remember, for your justification, we need to say who was oxidized and who was reduced. So chlorine went from a 0 to a -1. So chlorine was reduced. Oxidation number from 0 to -1. Br negative was oxidized. It went from a -1 to a 0.